So today we're going to talk about 2.5, linear function and models. And this is going to be a very short one. So we've already discussed some linear equation. Linear functions, I'm going to view them instead of an equation as a function, inputs and outputs. And we can express them in the form of ax plus b. Now, we are familiar with slope-intercept form, which is y equals mx plus b, which is the exact same thing. I just use a more general variable letter a instead of m, but they are equivalent. All right? In this case, a will represent your slope, b represents your y-intercept. So let's take this example. F of x equals 1 minus 5x divided by 4. Is this a linear equation or a linear function per se? Yes, it is, because when I'm dividing by a value, I can divide each term by the value and it will be equivalent. So 1 minus 5x over 4 is the exact same thing as saying 1 divided by 4 minus 5x divided by 4x. And then I can use the commutative property to rearrange them. If I do so, remember the negative here belongs to the term itself. So you have to keep track with it when you commute. And in this case, I have an a value of negative 5 over 4, and I have a b value of positive 1 over 4. This is my slope. This is my y-intercept for this linear function in this case. All right, let's take another one. G of x equals 3 times 1 minus 2x. This is a linear function as well because I can distribute these terms over or distribute this value over. If I distribute this value, I get 3 minus 6x. Again, this negative belongs to this term, and this 3 has a positive value. So I can commute them, rearrange them, and I get g of x is equal to negative 6x plus 3. This is my slope. This is my y-intercept. So we have that idea. Now to expand on linear functions, it has a constant slope or a constant rate of change. Remember earlier, I told you that it doesn't matter where you're at on the line. It will have the same slope all the way down here and all the way up here. They will be the same. No matter what 2 points you use on the line, they will hold true. Other types of functions, that is not true. So here's what I mean by that, or not what I mean by that, but let's take a look at that constant slope in particular. So in this case, I can draw a table to represent this function f of x equals 3x plus 2, and you're going to notice this constant rate of change. All right? This slope 3, we view it as a rate of change that's constant because if I increase my x value, my inputs by 1 in particular, we notice that all that happens to my outputs, it's going to be added by 3. Plus 3, plus 3, plus 3, plus 3, plus 3, plus 3. Now, if I increase my inputs by 2, however, it'll be increasing by 6, because 6 divided by 2 is 3. All right? Because remember, to find slope, it's the y values, difference in y values, over the difference in x values. But in this case, the difference in x value is just 1, so whatever I have for the outputs is my slope in this particular way. So that's how you can view a constant slope numerically or as a rate of change per se. All right, and that's going to really wrap up today because the rest you can find problems in your ebook in 2.5 in particular. They have some good application problems and whatnot. I think it's more practical and more efficient for you guys to actually look into those problems rather than cover that content in here. I will catch you guys next time. Take care. Bye.